Today we're going to talk about how to derive the Pythagorean identity. And we're going to begin with our unit circle. So we learned at the beginning of this unit that if we have a point on the unit circle, and in the notation we called like P of xy, we learned that if this angle here is theta, this point right here is cosine theta sine theta. And if we think about it in terms of the sides of the triangle, this is our x-coordinate, or cosine theta, and this is our y-coordinate, or sine theta. Now, the Pythagorean identity comes from the Pythagorean theorem, so we're going to review that quickly. The Pythagorean theorem says that if you have a right triangle with legs A and B, let's do it this way, A and B, and hypotenuse C, it is always true that A squared plus B squared equals C squared. So this applies to all right triangles. So it also applies to our right triangle inside of the unit circle here. So we're going to label the sides of this right triangle with A, B, and C. So we're going to call this B, this A, and the unit circle, the radius of it, is 1. And we're going to call this C. So let's go ahead and apply the Pythagorean theorem to this triangle right here. So we're going to have A squared, which in our diagram is going to be sine theta squared, plus B squared, which is going to be cosine of theta squared, equals C squared, which is 1 squared. And we pretty much have it. The only thing that I'm going to change is occasionally, actually not occasionally, most of the time, it's written this way. And that's how you come up with the Pythagorean identity.